Casimir. I'm one of the core developers of Socket.io. I'm interested in real-time scalability, hard distributed systems, basically everything that's really cool and awesome. I have my own startup. It's called Observe It. It's a real-time usability and user tracking. It basically allows you to follow all your users on your website and do all kind of interesting things with the data. In addition to that, I also work for Nodejitsu. I'm the lead software engineer there, and we host all your Node.js applications, and we're also one of the first hosting companies that support WebSockets. Woohoo! You can follow me on GitHub, on Fur-Eden, or on Twitter. And let's talk about browsers. I mean, it's one of the most important things about WebSockets. If you're looking at browser support for the latest RFC that's been created for the WebSockets, you see it's a decent amount of support that you have. You have Chrome 20, Firefox 12, Opera 12, but it's mostly targeting these high-level developers. Not all of your users will be having these kind of browser specifications. So if you want to have more browser support, you have to support more and older protocols, because the WebSockets has been in the browsers for a long time, just for experimenting and stuff like that. So if you want to have a larger or broader audience, you need to support like 2 or 3 different older protocols. And if you look at the browser stats, it's decent. But in the low bottom, you still have Internet Explorer 10. And come on, everybody's still using IE6 or 7 or 8. But 10? Nah, nobody. But that's not everything when it comes to browsers. There are a lot of big issues with WebSockets that most developers don't know. And for example, if you're using Safari, mostly the older versions, if you have proxy settings enabled or are using an HTTP proxy, it can actually completely crash your browser if you're just constructing a WebSocket. You just do new WebSocket and boom, your whole browser crashes or your tab crashes. And the biggest problem with this is that you can't detect it. You can try RabbitIn and try catch or maybe load the WebSocket in iframe, but it doesn't matter because your whole browser just crashes. And the biggest problem with it, most people don't even know that they have this enabled. I mean, it's really silly network check that's enabled on most Macs. Most people don't even know that it's on. So the only thing you can do is like this really horrible user agent detection. You have to scan the user agent string in the navigator to check if it's Safari and not Chrome, because Safari and Chrome are different. Because it uses a different network stack and JavaScript engine, and you have to parse out the WebKit version. And then if you have this match, you should not use any WebSockets. But there are more issues. If you are writing to a closed WebSocket connection on Safari Mobile, it can crash. And this happens mostly when you have an application and you put it in the background and do some other stuff and you come back again and your WebSocket connection starts writing again. And it just completely crashes just like before. But luckily there's a really smart workaround for it because it's just a race condition in a browser. So what you can do is you can wrap your WebSocket.send in a set timeout. This will give the browser enough time to fully propagate the closed ready state, and it will just prevent it from crashing. But the problem with this is you are using WebSockets to have like this really low latency connection. And it's just madness to add a really set timeout into it because it adds like 20 or 10 milliseconds of latency to it. So you really should only be doing this if you're on mobile. So that's something that you should be aware of. In addition to that, there's this really nice Firefox bug. I mean, most of you are probably working on games or are building these amazing web UIs, and you have these modal dialogues. And what users are usually doing when they want to close it? They are either clicking on the nice cross or pressing escape. Same with games. If you want to pause the game, you press escape. But in Firefox, it's actually canceling and closing all network connections that you have established after the download. And this bug has been present in Firefox for a really long time. They just recently fixed it in Firefox nightly, but it's something that not most developers think of. The fix is really simple for it. You can just listen to the key presses on your browser and determine which key is pressed. And if it's the escape key, you can just call the prevent default handler in the browser, which will prevent all default actions of your browser, and therefore stopping all these issues. Another thing is, which can be annoying when you're working locally with WebSockets, is that you're probably using self-signed certificates. But the issue with this is that these browsers don't know how to handle self-signed certificates when they're connecting. So you basically just have a broken connection. The only thing you can do is just use a proper certificate, or just don't use WebSockets, because it's the only option that you have. There's another bug in Firefox. It's that you cannot connect to an unsecured WebSocket from a secure page. I mean, this makes sense if you think about it. But the problem with Firefox is that they're actually throwing an error. And if you're not aware of this, this can just completely mess up your application. But again, nobody in their right mind would probably connect to an unsecured connection from a secured web page. And there's another bug in Firefox. I mean, it's creating these ghost connections. When you are trying to reconnect to a WebSocket again, if you've have received a close event, it will actually create a loop. But this works already. This works really nice. But if you're going to a different page, it will call the close handler again and create a ghost connection for you. And the problem with these connections is they don't go away when you close your tab. You actually have to close your complete browser to shut down these connections. And it's not detectable. And there are no real fixes for it. You can try to maybe listen to their own close events or on before handlers, or on before close handlers, and set a flag in your applications to not reconnect your WebSocket. But it's annoying because it's just wasteful. Another thing is a lot of mobile users are not always connected to Wi-Fi. You have 3G, 4G, LTE. I mean, all these network providers are basically trying to optimize your mobile connection. And what they do is they stick a reverse proxy in front of it to serve back content much faster than the origin servers are possible. But all these reverse proxies don't support WebSockets. I mean, some of them do, but some of them don't. I mean, you have AT&T has some issues with LTE, and you have Vodafone with issues. You have O2 with issues. I mean, all these different providers, it's a mess. The only thing you can do about it is basically just completely stop using WebSockets on mobile. I mean, it's an option. An alternate to this is just to use a secure WebSocket connection, because most reverse proxies don't know what you will be sending and therefore allow this connection. So let's talk a bit about infrastructure. I mean, everybody is building these real big application, and you have like these great boxes in front of your servers. You have like thousands of little application servers and millions of clients, but you have to have something in between to route all those traffics. And that's usually a load balancer or a reverse proxy. But there aren't that many reverse proxies that actually support WebSockets. You have AT proxy, which does this in TCP mode. The problem with this is that you can't rewrite headers or, for example, send the IP address of the user back to your application servers. Another option is using the HTTP proxy, which is built by Nojitsu. It's a really nice library, but it's a library, so you still have to build all the infrastructure yourself for it. But recently, they have been working and developing a couple of big changes in the development branches of other proxies. For example, we have also Nginx and Apache, but nobody's using Apache, right, for proxy. I mean, come on, it's madness. But Nginx is a really viable option. I mean, Heroku is also using it, but it's one of their main issues why you can't deploy WebSocket connections on Heroku. They're using Nginx as reverse proxy. But in the development branches of these proxies, they actually managed to bake in WebSocket support and SSL termination. And that's something that you really want to have in your application. You want to have SSL termination to reduce the overhead of SSL, so you have faster connections, and you have WebSocket support. I mean, it's amazing, but it's still in development. But you have to ask yourself, which of these proxies are the best? I mean, you have like 3 really good different solutions. So what I've done is I've been starting some testing on different reverse proxies and try to see how they all compare. And it's really similar. If you look at HTTP proxy, it's a bit slower on the handshake, but these stats are performed with HTTPS. And the HTTP proxy is built on Node, and Node isn't that amazing with SSL connections. So you will have a bigger lag here. So one thing you can do is add a SSL terminator in front of it, but it's not that fast. But if you look at Nginx or HA proxy, it's really fast and it has really low latency. So these are really viable options to deploy on your own infrastructure. So check it out. All the results are on GitHub, on GitHub/observing and balancer battle. Means all the results for HTTP and HTTPS. In addition to load balancers, we don't have any viable tooling for WebSockets. We have WSSH or WSCAT, which is basically netcat for WebSockets, which you just open a WebSocket connection and you can type anything you want to it, and it will be sending it to the WebSocket. And you have a couple of benchmarking tools. You have WSBench and WebSocket Benchmark. But the problem with these tools is that they're incomplete or out of date. So what I've done is I've built my own WebSocket benchmark tool. It's called Thor. It's the god of thunder, son of Odin, and the smasher of WebSockets. And it basically helps you figure out all these stretch points in your infrastructure. It can send different types of messages. It can send binary messages, UTF-8 or mask messages. And it also gives you a really nice results of the latency or how long it took to handshake with the server and receive a completed connection. It's open source, like all of my code. So check it out if you want to stress test your WebSockets. But there are also things with WebSockets that we can't control, and this is the user environment. And you have these browser extensions that people are using that we don't have any control of. We have a firewall that people might have been installed on their local machines or maybe even on a proxy server in their office. And you have these aggressive virus scanners. And you have proxies that target these or basically block everything that isn't a web port. So they only allow like port 80 or 443 or 843. And if you're looking at virus scanners, they are exactly targeting those ports because that's where all the garbage comes from. So you have like these two processes trying to control everything that you send over the internet, and it's actually blocking all of your connections. In my previous employer, we had a real-time auction site, and we used WebSockets to send all these bits between all different connected users. But we started receiving phone calls from all these users. We can't connect, and what's going on? And after some inspection, we found out that all these users are either behind enterprise proxies or have these really aggressive firewalls installed. For example, Avast blocks WebSockets on port 80, and while others are just less aggressive on that. And that's the default settings. And you have this firewall called Blue Code, which is actually scanning all the scripts that are loaded into your page and search for the occurrence of ActiveX. And if it finds it, it will completely just block the socket, the script. So it's really annoying to have a working WebSocket connection when the environment that you are deploying in is really hostile. So these problems are later again confirmed by Battlefield. They built this really cool chat, and they also received all these issues. So it's a really big problem when you want to deploy these real fast real-time applications. It's something you need to be aware of, that it can happen. So you must provide fallbacks in order to have a sustainable working connection. So what are we actually dealing here with? Some stats. I mean, everybody loves stats. If you look at WebSockets, you see like 70% or 80% around that ratio is supporting WebSockets. So you have like this 20–30% group of users that don't use WebSockets. You have to supply a fallback for it. For example, using long polling, short polling, or something like that. And from all these WebSocket users, there's like this 8% of connections that cannot connect using WebSockets, even though they support it. If you dig a bit deeper in it, you see like there are people without proxy who failed the connection, and even with proxy have failed the connection. It's a bit of a mess. But if you compare it to the WebSockets that are enabled in browsers and to the success rate, you see it's decent, but it's not okay, especially if you start comparing it with Comet. Comet has a much higher success rate because it's not using WebSockets, for example. And in Chrome, it makes a really big difference because we have like 99% success rate with Comet instead of with WebSockets, you have like 93%. So what does this all mean? When you deploy WebSockets, always use SSL or Speedy. You should use Speedy because it multiplexes your connections. If you're using polling, for example, it's a lot faster on mobile because just using one connection instead of multiple connections. And the SSL and the inherent security of Speedy just makes it more resilient for these transparent proxies. Avoid WebSockets on mobile, but only do it when it makes sense. There are a couple of benefits when using WebSockets on mobile. For example, you have better battery life because you're not continuously polling your server. But it can also cause all these issues with what I've been talking about. So it has to be a decision that you have to make for yourself if it makes sense to support or enable WebSockets on mobile. Also, know your framework internals. Most of you will probably not be using raw WebSockets, but are using a framework. For example, Faye, XSocket, SockES, Socket.io. But not all these frameworks solve all these issues that I've been talking about. And that's something you need to be aware of. Just because you're using a framework, it doesn't mean you have a successful connection. And do you really need it, or are you just following a hype? I mean, WebSockets are awesome, but are you just using it because it's cool, or is it really needed for application? For example, if you have a dashboard and you want to stream in logs, it doesn't make any sense to use WebSockets because it's bidirectional. You might be better off just be using event stream or server sent events, because that just streams data from one side, from the server to your browser, and that makes a lot more sense. And it's just plain HTTP, for example, and you don't have all these issues with it. So justify your usage of WebSockets. And when you do use WebSockets, always provide fallbacks. This way we have the most coverage. What most frameworks have been doing is using WebSockets as the first connection. And then they fall back to different load transports who are generally less performant. But as you know, you have these annoying proxies that block everything. So instead of doing downgrades, you should actually be doing upgrades. So you start at the lowest, which will probably be JSON polling or HR polling. When you have settled a good, solid connection with it, you start probing different connections with different transports. And if those connections succeed, you just upgrade your connection to that transport. And you just go up until you reach WebSockets. And there you have this decision. Do you want to just support WebSockets on port 80 or just secure WebSockets? Or do you want to go further and do even more advanced port upgrading? So this was my talk, and go forth and be awesome. Thank you.